In the previous video, we discussed the heat conduction equation in a large plane wall. In this video, we'll explore the heat conduction equation in a long cylinder and a sphere. Let's imagine we have a cylinder with a length of L and a normal surface area A, as illustrated in the figure before you. To facilitate our study, we'll focus on the top surface of the cylinder. Now consider a thin shell element of thickness delta R. The area of the cylinder normal to the direction of heat transfer at any location is A, where R is the value of the radius at that location. Note that the heat transfer area A depends on R in this case, and thus it varies with location. An energy balance on this thin cylindrical shell element during a small time interval, delta T. After substitution, the balance equation takes the following form. We then proceed to substitute both the change in the energy content of the element and the rate of heat generation within the element into the previous equilibrium equation. Now dividing the equation above by a delta R from the definition of the derivative and Fourier's law of heat conduction, and taking the limit as delta R and delta T to 0, noting that the heat transfer area in this case is A. So we get the one-dimensional transient heat conduction equation in a cylinder for variable conductivity, and this is for the case of constant thermal conductivity, where again the property alpha is the thermal diffusivity of the material. So the equation reduces to the following forms under specified conditions: steady state transient and no heat generation, steady state with no heat generation. And that's all about heat conduction equation in a long cylinder. We repeat the same method in the case of heat conduction equation in a sphere, except we replace the area of the cylinder by the area of sphere.